Hello, grade 11s. Please bear with me. My voice is awful. It's been coming and going. So, today we're going to start our new unit, which is the property of angles. Today, we're going to be drawing a lot of the different examples and drawing diagrams of everything that we go through. So, if you do not have a ruler, please grab one. There's some in the front of the classroom in the classroom supplies bin. Please feel free to grab them. But otherwise, we are going to get going. So as we go through today's lesson, we're actually going to go through a whole ton of definitions. Now, all the definitions are already written for you. So what we're going to be doing is not really writing any of the definitions down, but we are going to be drawing diagrams of the definitions so that we can help identify them in different situations. And for a lot of these, we're going to be drawing more than one diagram just so that we can see what it looks like in more than one way. So that's kind of going to be our game plan. And then once we have all of those definitions and we have an understanding of those definitions, we're going to move forward into some different properties and relationships and identifying those definitions in diagrams. So we're going to get right into it. The first one is vertically opposite angles. Vertically opposite angles are angles that are opposite each other when two or more lines intersect. Vertical, the word vertical is a description word, and it simply means that they share the same vertex. Vertically angles are congruent, which is just a math word of saying that they are equal to each other. So if I'm drawing vertically opposite angles, I need to have two or more lines that intersect. So I'm going to draw two lines. And it doesn't matter how these lines are drawn, I just have to make sure that they intersect. Lines go on forever, whereas line segments don't. So either way, vertically opposite angles can exist on intersecting lines or line segments. But here I'm drawing two lines. I can tell because the arrows are on the end. Now, the point in which they cross is called the vertex. I'm going to label that. That's the vertex. Now, opposite means that they are across from each other, right? If you're sitting at your table right now, the person next to you isn't opposite you, but the person across from you is, right? So when we talk about vertically opposite, we're talking about one angle and the one that is across from it or opposite from it across the vertex. Now there's two pairs of vertically opposite angles here, so I'm going to draw them with different markings. So those two pinkish red ones are vertically opposite, and these blue ones are also vertically opposite. In the definition, part of the definition was that these two angles, the vertically opposite angles, are congruent to each other. Which means if I told you this angle, this pink one over here, was 45 degrees, then I would know that this other pink one would be 45 degrees because they are congruent. Okay? All right, that's true for just two lines that intersect, but it's also true for more lines that intersect. So I'm going to draw a set of three intersecting lines. And again, it doesn't really matter how I draw my lines here. I just care that they all intersect in the same spot. And when I do that, three lines that intersect will form three pairs of vertically opposite angles. So these two light blue ones would be considered vertically opposite. These two light purple. And these two green. And again, just like before, the point of intersection is called a vertex. And that's true when lines intercept, but it's also true when they just simply meet. I guess it's still intersecting, but when they just meet, like if I drew like a rectangle, when two line segments come together to form the edge of that rectangle, that corner is called a vertex because it's just where two line segments meet each other. So that's vertically opposite. Next one, Supplementary. Now, supplementary angles are ones that you would have seen before, so this shouldn't be too new. But supplementary angles are simply two or more angles that add to 180 degrees. So together they form a straight line. Now, supplementary angles do not have to share a vertex, but they can. So say, for example, I have this line here. It is 180 degrees, a straight angle on its own. But let's say I split it up into two separate angles. So I have this one here and this one there. These two angles create a supplementary pair. They add to 180 degrees. Together they form a straight line. Now, this is very true. They can share a vertex, but they don't need to share a vertex. So say, for example, I have two angles, and they aren't sharing a vertex. They each have their own separate vertex, right? But their total can still add to 180, which would still make them complementary. So let's say if this guy was 50 degrees, this one would need to be 130 degrees to make it a supplementary angle. Oftentimes, if we're talking about angles here, we would say the 50-degree angle is a supplement to the 130-degree angle, or vice versa. Okay? When we talk about supplementary angles, of course, they do not have to just be two angles. They can be, much more or much few, or well, not much fewer, but they could be much more. So here's 4 separate angles. 1, 2, 3, 4. That together are supplementary. They all add to 180. They together form a straight line. Supplementary angles do not necessarily have to be congruent to each other. They can be. So I could have a 90-degree and a 90-degree angle. But the key premise here is that they all add to 180. All right, interior angles of a polygon. So just a quick reminder, polygon is any shape that is formed with straight lines. So a square, a triangle, a pentagon, an octagon, those are all examples of polygon. Poly just actually means many. Poly is just the prefix for many. Gon means sides. So when I talk about polygon, I'm just talking about many sides. Okay? When I talk about a polygon, a circle is not a polygon because a polygon is only formed using straight lines. Okay, so an oval is also not a polygon. A heart is not a polygon. So I'm going to draw a couple of polygons here. So I'm going to draw, a crowd favorite, a rectangle. I'll draw a triangle here. And then I'll just draw, what I get here. Oops. Let's see what if my iPad will discern any shape. It will not, but that's okay. I'll try and draw it a little bit more clearly. Oh, there we go. Here is a pentagon. Okay, all of these are polygons because they're all formed with straight lines. Now, that wasn't what we were getting at here. We were talking about interior angles. Now, the next one is about exterior angles of the polygon. So before I actually do any labeling, I'm going to copy my same exact diagram below so we could point out the similarities about interior angles and exterior angles. So, interior, we've heard that word before. It's just kind of like another word for inside. So, it comes to no shock that interior angles are the angles inside. They are formed inside my polygon. So, all of these angles that I'm putting little markings on are examples of interior angles. Now, when we talk about exterior angles maybe aren't as obvious to us as maybe interior angles were. Exterior angles are actually formed when I take one side length of my shape, so let's say I'm talking about the side length here, and I extend it past the shape. An exterior angle is the one that is formed between the outer edge and that extended side. So if I'm taking a look at all of my shapes here, if I'm extending each of these sides, an exterior angle is always going to be the angle formed between one of the outer sides and the extended sides. So up above, these were interior. But on the bottom here, we'll maybe label them in a different color. These ones are exterior. So it's formed from an extended side and one of the pre-existing sides. Now, something that's kind of interesting to note is that an interior angle and an exterior angle that is adjacent to it, it's adjacent, or the exterior angle that's immediately beside it, will be supplementary to each other. Right? This blue one is interior. The pink one or the red one is exterior. And together, those angles will be supplementary, which means that they add to 180 degrees. So I could say the interior angle plus an exterior angle will equal 180 degrees. So if I know one, I can find the other. That is always, always, always true. Okay, so that's our first set of angle properties, but we have much, much more. Now, as we go through some of these, some will be familiar to you, right? I'm expecting supplementary to be something that you've heard and seen before. Vertically opposite, maybe, maybe not, okay? But as we go through some of these might be really new, some of them might not be. But we want to really focus on the different names and the different relations that they have. So if there's a point of congruence, if some angles are supplementary to each other, etc., that's going to help us down the road when we find missing angles in a diagram. Okay, moving on, parallel lines. Now, parallel lines are any two or more lines that are always equidistant apart at any given point. These lines will never intersect or touch. When we talk about parallel lines, okay, I'm going to just draw two exact parallel lines. These parallel lines will never touch or intersect. Now remember that the arrowheads at the edge of these lines imply that they go on forever. So even if I'm taking a look, I draw like another line right here that right now doesn't actually touch a line. It is not considered parallel because if I did extend it on forever, it would eventually cross, right? So parallel lines are always going to be equidistant apart. So this distance is equal to this distance is equal to this distance. Always, always, always. Now parallel lines have symbols on them quite often to help indicate that they are parallel, because it's really hard for the human eye to detect if they are actually perfectly parallel or if they're not. But it's also really hard to draw perfectly parallel lines. So symbols exist to help kind of get away from that ambiguity. The symbol that we use to indicate that lines are parallel is that we put extra arrowheads in the middle of the line. Now, the number of arrowheads we put on there helps us differentiate one set of parallel lines from a different set of parallel lines. So when I'm talking about this first set here, I only need to have one additional arrowhead to indicate that they're parallel, because that's all that I need. There's nothing else comparing it to. But if I drew another set of parallel lines, right, I want to also indicate that these are parallel. But if I put the same one arrowhead on there, then technically the symbol implies that all four lines are parallel. And we know that's not true, right? So to differentiate one set from another, we just double up the symbol. So two arrowheads instead of one will indicate that those two pairs are each individually parallel, but not parallel to each other. Other things is that when we're talking about parallel lines, sometimes we don't actually say that they're parallel by putting in those parallel symbols. Sometimes we might just label the lines, give them names. And what names we give them can either be based on two letters or a lowercase kind of letter here. So I'm going to call my first line M and my second line N. And these lines are parallel. I haven't drawn symbols on them, but another way that I can shorthand express that they are parallel is I can do this. I can say line M is parallel to line N. Now this symbol here, these two kind of slightly slanted but longer lines than the lowercase l, okay? That's the symbol that indicates that lines will be parallel to each other. So if I had that in a question, but I didn't have those little like extra arrowhead markings on my lines, I could go ahead and add them so that I can better visualize that, okay? So it's different ways to indicate lines or parallels. I can draw the arrowhead symbols in the middle, or I could have a math statement using that parallel line shorthand symbol. Okay, next definition, a transversal. A transversal is a line that intersects two or more other lines at distinct points. So I'm going to have two or more other lines just casually about. So I'm going to draw two or more lines here. I'll start with two in this first example. And a transversal is one that intersects them. So here's my transversal. My transversal line is this one here. It's the one that I've highlighted in yellow. It is my transversal. Because it intersects two or more lines at distinct points. Now, this vertex and this vertex are both distinct points. Okay, now that transversal can intersect any number of lines. So in this particular diagram, I have a transversal intersecting two lines. But I'm more than okay with, I don't know, let me draw 3 lines. They all happen to be parallel in this case. It doesn't actually matter what those other lines are. But if I want to draw a transversal, I just need to make sure I'm intersecting them. So this here, this yellow highlighted line is my transversal. And these are all distinct points. Okay, now something really cool kind of happens when we have a transversal intersecting parallel lines. Now, the next couple of angle properties that we're going to be looking at are going to have some pretty cool features when we start talking about a transversal that intersects parallel lines. So, the first property is going to be exterior angles of parallel lines, followed by interior angles of parallel lines. Now, in both of these cases, it's not just the parallel lines that exist. It's a transversal that intersects two parallel lines. I mean, in theory, it could be 3 parallel lines, 4 parallel lines, etc. But we're going to focus on a transversal intersecting 2 parallel lines. So let's start by drawing 2 parallel lines. And we are going to draw the transversal. Now, my parallel lines, I am going to indicate with that extra arrowhead symbol to make sure it's super clear to whoever's looking at my diagram that these are in fact parallel. And I'm going to draw a transversal. Doesn't matter the angle in which I draw it. This is my transversal. Oftentimes we indicate a transversal with a lowercase t in diagrams. Now notice that when my transversal intersects my parallel lines, I have a bunch of angles formed. Okay, I'm going to draw on this, but I'm going to erase it right away, so don't copy this down, right? I have 1, 2, 3, 4, 5, 6, 7, 8 angles that are formed. Okay. Now when I look at those 8 angles, some of them are inside my parallel lines, and some of them are on the outside of my parallel lines. Okay, how I like to sometimes visualize this. Have any of you ever been to a restaurant and you get like a really big burger? Okay, this is my burger here, my sesame seeds. Okay, and inside my burger, I don't know. Maybe there's some sort of patty. I don't know what it is. Maybe there's some lettuce. Whatever. But sometimes the burger is so huge that they put a skewer in it, right, just to hold it together. Now, when I take a look at this, my buns, I suppose, are made from those parallel lines, okay? And when I talk about a sandwich, I think it's really clear when I say what's inside my sandwich, or like, okay, what's between the 2 buns, okay? I'm going to be using that analogy when I talk about interior angles and exterior angles here, because I feel like it's a really clear way to help interpret this. So I'm visualizing these 2 parallel lines as the buns of my sandwich or my burger or whatever I'm eating. And when I talk about interior angles or exterior angles, I'm going to be talking about the ones inside my sandwich, so between the buns, or the ones outside my sandwich, so above or below the buns. In this particular example, we're talking about exterior angles. Exterior angles are going to be the angles that are outside of my sandwich. So they're going to be above or below those buns. So this angle here is exterior angle of parallel lines. Same with this one next to it. I also have this one down below, followed by this other one. Now when I have 2 parallel lines that intersect, or that are intersected by a transversal, I will have 4 exterior angles. Now something to keep in mind is that it doesn't actually matter what orientation the diagram's drawn in. I can still picture my burger. Now, of course, I want my burger to be relatively flat on my plate because that's the easiest way to hold it together. But it's possible that when I get my burger, maybe the waiter tripped, who knows? But maybe it's a little bit more disheveled. Okay? So it's actually completely on its side here. The same kind of rules exist, or the same concepts exist, is that my exterior angles are those on the outskirts of my bun. So it's this one, and this one, this one, and this one. There will always be 4 exterior angles. I'm going to go ahead and label my transversal with a little T as well, just so we can kind of point those out. Okay. Now we've talked about exterior angles of parallel lines. We could also talk about interior angles of parallel lines, which is kind of just the opposite of whatever we just spoke about. So I'm actually going to redraw these exact same diagrams. And I'm now going to label the angles that are inside my buns or inside my sandwich. Oops. So I was going to draw the same one, so I'll draw the same one. I'm labeling my transversal I'm indicating my lines are parallel with those symbols. But in this particular case, my interior angles are going to be the ones inside my sandwich. 1, 2, 3, 4. Okay, and again, that doesn't matter the orientation of the sandwich here. It can be relatively stable or, relatively in the direction that we typically eat sandwiches in. Or it could be completely on its side. But again, same idea. Oops, I should label my transversal. And I will go ahead and label my parallel lines with the extra arrowheads. Putting 2 on this set because it's different than the first set. Okay, and my interior angles are going to be inside my sandwich here. Okay, that is our exterior angles and interior angles of parallel lines. Now, we are going to start getting into different angle properties that uses those parallel lines and the transversals. But it's going to be really important to distinguish the difference when my lines are parallel and my lines are not. So we're going to go through these. But the first one that we're going to go through is called corresponding angles. Now, corresponding angles exist when I have 2 lines intersected by a transversal. Okay? So I'm going to draw 2 lines. I'm not going to worry about these first 2 lines being parallel. Actually, I'm about to draw 6 diagrams here. Okay? So just be mindful space-wise. I'm going to space these out because I'm about to draw 6 sets of these. So please also be mindful in your own notes. So in this first set, I have 2 lines and a transversal. Now these lines are not parallel, as we can clearly see, but I'm also not indicating them with a parallel line symbol. Okay? And corresponding angles are those in which one is exterior and one is interior. So one's on the outside, one's on the inside. They are not adjacent, which means they are not next to each other. Okay? And they lie on the same side of the transversal. So, I'm going to take a look, and I'm just going to start with any one exterior angle, because I know one exterior angle has to be involved. So I'm going to pick this one. Okay? Now, I need my other angle to be interior. I'm going to label all interior angles, but I'm going to delete this after, so you might want to pause. 1, 2, 3, 4. These are all interior angles, okay? Now, I want that interior angle to be non-adjacent, which rules out this one. Great, because that angle is adjacent. It's immediately next to it. It shares a side with that other angle. I also want that interior angle to be on the same side as the transversal. Now, when I take a look at the transversal, there's the right side of it, there's the left side of it. Since my exterior angle is on the right side, I want my interior angle to be on the right side, which means the left sides are not available. With that being said, this remaining interior angle after we crossed out a whole bunch of them, would be considered the corresponding angles. Okay, I'm going to draw a second example where I have 2 lines and a transversal. I'm going to draw roughly the same diagram. But I'm going to pick a different exterior angle. I'm going to pick this one. I'm going to go ahead and make sure my transversal is labeled with a T. It's clear. And again, this transversal is going through 2 lines that are not parallel. Now again, if I want to take a look at what interior angle it would be corresponding to, it cannot be adjacent, so it's not this one, and it has to be the same side as the transversal. Right now my exterior is on the left, so I can't be talking about any interiors on the right. Okay? So this one here would be my corresponding angle. Now in this case, when my corresponding angles exist on non-parallel lines, just regular lines that are not parallel, these corresponding angles are not equal to each other. So corresponding angles, they're still corresponding, but not equal. They are not the same angle measure. So if I have this one that's, let's say, 100 degrees, that doesn't tell me anything about this one. Now, something that's really cool about corresponding angles is that if my corresponding angles happen to be on parallel lines, the two angle measures will be equal to each other. Each pair of corresponding angles on parallel lines will be equal to each other. So we are going to draw the same diagram 4 times. And the diagram that we're going to draw is going to be of 2 parallel lines and a transversal. Okay, take some time and draw that diagram 4 separate times. The reason that we are drawing it 4 separate times is because there are going to be 4 different pairs of corresponding angles that are going to be equal to each other on this particular one diagram. So I'm drawing the same diagram so I could just point out each individual pair, but there's 4 separate pairs, which is kind of neat. So in each of these pairs, I am going to indicate a different exterior angle to start off with. So here I'm going to indicate this exterior angle. Here I'll do this one. The bottom I'll do this one. And here I'll do this one. I want you to pause the video for a couple seconds and try to find the corresponding angle for each of these diagrams. Go. Okay, hopefully you paused. I'm going to go through these and go through them with you. So for the first diagram, this angle would be corresponding. The second diagram, this angle corresponding. Third diagram, this angle corresponding. Fourth diagram, this angle corresponding. In each of these, the definition still holds. It's an interior angle that is non-adjacent and on the same side as the transversal. But for all of the 4 diagrams we just completed, all of these angles are corresponding on parallel lines and are equal. So if I know the measure of one of my corresponding angles in that corresponding angle pair, I will automatically know the other if the lines are parallel. If the lines are not parallel, then the corresponding angle pairs are not equal to each other. But if the lines are parallel, each pair of corresponding angles will be equal to each other. Okay. Looking at the next one. The next one, we're talking about alternate interior angles of parallel lines. So again, we have my parallel lines. We have our parallel lines. We will also have that transversal, okay? But when we talk about our alternate interior angles of parallel lines, we are going to talk about two non-adjacent interior angles that are on opposite sides of the transversal. So let's start with the diagram, okay? We're going to draw two parallel lines. I'm going to use the markings to indicate that they are parallel. I'm going to draw a transversal. I'll label it with a little t. And then we'll take a look at the definition. The definition talks about two non-adjacent interior angles on opposite sides of the transversal. So I'm just going to start off picking one interior angle. So I'm going to pick this one. Now the definition says that these interior angles are not adjacent, which automatically rules out this one, right? Because those two angles, the blue and where I've drawn the X, are adjacent to each other. They are next to each other. So that's out of the question. These two non-adjacent interior angles have to be on opposite sides of the transversal. My blue angle is on the left of the transversal, which means I cannot have another angle on the left, which means the other interior angle or alternate interior angle I'm talking about here must be on the right. So these two angles of parallel lines will be alternate interior angles of parallel lines. We're going to draw another diagram. I'm just going to change up the orientation of where the parallel lines are directed so that we can still indicate them. So I'm going to draw two parallel lines. These parallel lines are going to be going off in a different direction. I'm going to have a transversal. Okay. I'm going to label all my things so my parallel lines will have those symbols. My transversal will be labeled with a nice T. And I'm simply going to pick one interior angle. I'll pick this one. And find the other. Okay? The other one cannot be adjacent. And it cannot be on the same side of the transversal. Here, my green angle was on the bottom. So the other angle must be at the top. So these are my alternate interior angles of parallel lines. Now, we are going to talk a lot about different relationships, and I get it that today is really content heavy with different names and just identifying different relationships of angles and where they're located and all of that stuff. But all of the things that are important is like understanding the diagram. Of course, the diagram we drew, but if I gave you a new diagram, could you still identify what angles are what relationship? And the names of the relationship. It's also another really important thing, knowing the difference between corresponding versus supplementary versus alternate interior versus interior angles of a polygon, right? The names are important, as well as the relationships, right? So there's three things: the diagram and identifying them, the names, and the relationships. Now, so far in this this name here, the alternate interior angles of parallel lines, we've talked about the diagram and we talked about the name. But there's also a relationship that exists. Now, we aren't going to just accept the relationship as is, but we can actually prove that a relationship is true. And that's right, I said prove. The reason we did the first unit, we did first inductive and deductive reasoning, is because we can now use our skills of proofs and apply them to new situations. So, there is a conjecture. The conjecture is when a transversal intersects a pair of parallel lines, the alternate interior angles must be equal. We are going to prove that conjecture. Now, just a reminder from our old unit, there was three things that a proof needed to have. The first thing is we started with that let statement, a generalization indicating what parameters we were introducing to our proof, right? We used 2x to represent an even number. We used 2x plus 1 to represent an odd number. We used different variables for different parameters that we were involving. When we're talking about lines, it's a little bit different, but it's also a little bit similar. We are going to have a let statement, but our let statement is going to be accompanied by a picture. Because how can I talk about lines and talk about angles and have you, the reader of the proof, visualize the exact same thing that I'm visualizing my lines to do? So our let statement in this unit is actually going to be accompanied with a diagram. The second step of our proof was our math work. We're still going to have some math work. Our math work will obviously have some math, but it will also have statements of how we know that the math that we're using is true. Because we're not necessarily going to be doing addition or subtraction all of the time that we would have been doing before, or multiplication, division, squaring, etc. But we're going to be talking about things that are equal. And we need to kind of justify how we know things are equal. We need to rely on some of the other facts and some of the other skills we already know. We are also going to be using the deductive reasoning by using the transitive property quite a bit. Remember, the transitive property is when we had one fact and another fact, and we were able to link those two similar facts together to create a third, okay? We are going to do something similar here as well. The last thing our proofs needed was a therefore conclusion statement. We are going to make sure that we also have a therefore conclusion statement. So we're still going to follow the 3 steps of a good proof, except it's going to look slightly different because the context that we're working in now is less algebraic, but can still, apply those skills here. So we are going to do our first proof. So we want to prove that when a transversal intersects a pair of parallel lines, the alternate angles must be equal. Which means this is the condition I need to start off with. This is what I want to prove. That yellow chunk, I need to introduce as part of my let statement. I need to have a transversal intersecting a pair of parallel lines. So we are going to do that. We are going to draw a diagram that has 2 parallel lines and is intersected by a transversal. So this is my first step here. Now remember, we said that our first step is usually a let statement, and that let statement's accompanied by a diagram. Well, here's the diagram. Now I need to make sure it's explicitly clear that I'm introducing what the diagram represents. So I'm going to actually label the line so it's easier to talk about in words in my let statement. I'm going to call the first line, line 1, and the second line, line 2. And my let statement's going to look like this. It is going to say, let L1 be parallel to L2. And be intersected by transversal T. That's it. My let statement is simply describing what I just drew. Now, of course, I used the double slashed lines to indicate the words be parallel to, but you can write that in words as well. So instead, you could say let L1, and in here I could write be parallel to L2, right? We can write that out in words. The symbol isn't necessary. It's just a different way or a shorter way to represent it. Kind of like how we use the 3 dots in an upward facing triangle to represent the word therefore. It's just a math shortcut. Now, we want to talk about alternate interior angles, and we need to prove that they're equal. Now, we can't just be like, look at them, they're equal, right? They might look similar to each other, but we can't prove that by just saying it's true. We can prove it by using some of the other properties that we've talked about, though. We've talked about vertically opposite angles, we've talked about supplementary angles, and we've talked about corresponding angles, okay? Now, in my diagram, I have 8 angles there. And I want to be able to, talk about an angle and you to know what angle I'm talking about. So, what would be helpful is for us to label those angles. Now, I'm a big fan of just labeling those angles with numbers. It doesn't actually matter what numbers you use, as long as you don't use the same number twice, like I almost accidentally did. But you could technically also label them with letters. You could also label them with symbols. It doesn't matter as long as the reader knows what you're talking about. Okay, if I say angle 2 right now, I know that even though I am not there, you know exactly what angle I'm talking about, because now you're looking at my diagram and you're like, oh yeah, it's clearly the one labeled with a 2. Okay, now, just like we talked about before, there's actually more than one pair of alternate interior angles. I'm going to highlight them, but then I'm going to get rid of the highlighting right away so I don't copy it down. 3 and 6 are actually alternate interior to each other, but so are 4 and 5. Now, I don't have to prove both pairs are going to be equal to each other. I just have to pick one pair. And because I have options here, I want to make clear what option I'm going with. So when I'm taking a look at this example, I have to pick one. Now, I don't actually care which one we pick. We could pick either. I'm going to pick 4 and 5, just because. Now, when I take a look at 4 and 5, that's my goal. My goal is to prove that those two things are equal to each other. I don't know that they're actually equal right now, but it's my goal. Just like I said before, how there's multiple options here. I could try and prove that 3 and 6, those angles are equal to each other, or 4 and 5 are equal. I want to make it clear to whoever's reading my proof what my goal or my intention was. So I'm going to actually write it down as a goal statement. This is not necessarily true right now, but it's just a goal. My goal is to prove that angle 4 is equal to angle 5. Now, I don't know that that is true. That's why I had the word goal in front of it. But that way you know what my intentions are. Now, something important, I need to write the angle symbol in front of the number 4 and 5 because I'm never trying to prove that the number 4 is equal to the number 5. I know it is not. But angle 4 is possible to equal to angle 5. Okay. Now, how I'm going to do it. Like I mentioned before, my goal here is to use the transitive property. AKA, I'm going to try and use two facts that connect to each other to come up with a third kind of conclusion fact. Now, what I'm trying to do is I'm looking at angle 4 and I'm looking at angle 5, and I'm trying to think of all of the angle relationships I know, specifically that exist in this diagram. Right? I don't really care about interior, exterior angles of a polygon. I don't have polygons on this diagram, so it's not really useful to me. But I am looking at supplementary, I am looking at corresponding, I am looking at vertically opposite, because those are all pairs of angles that I have in this diagram. Now, I want to find an angle that has a relationship with both 4 and 5. And that angle is the same. So I might look for angle 2, let's say. Again, I'm going to try things and erase them. Angle 2 has a relationship with angle 4, right? They are supplementary to each other. But there is no angle relationship between 2 and 5 that I know at this moment. So I'm not going to choose angle 2 as my middleman or as an angle, kind of a fact that I involve, because it's not going to help me reach my goals. But if I choose like angle 1 here, I know angle 1 and angle 4 have a relationship. They are vertically opposite. And angle 1 and angle 5 have a relationship because they are corresponding angles of parallel lines. And that's going to be helpful to me. I want to find an angle that has a relationship. Now, something I want to be aware of is that the relationships I choose need to actually be more than just like a general relation. And what I mean by that is in vertically opposite angles, I know those angles are equal to each other. In corresponding angles of parallel lines, I know those angles are equal to each other. I would not want to choose angle 6 because even though 5 and 6, those two angles add to 180, there's a specific math that's related to them. Angle 6 and angle 4 don't have a specific math relationship. Yes, they are technically both interior angles, but I don't know anything about what that means. It doesn't mean that they're equal. It doesn't mean that they add to something. They just exist. So I want to pick an angle that has two clear and mathy relationships to angle 4 and angle 5 because that's what I'm going to use to help me prove this. I'm going to use that math. So I'm going to use angle 1 here. And what my proof is going to look like is I'm going to write down the facts I know with my angle 4 and my angle 5 with that new angle I've indicated. So my first one is angle 4. I know is equal to angle 1. Why? Because they are vertically opposite. So I'm stating the math equality that I know, or the math statement that I know to be true. And then I'm stating why I know that. Because I can't just willy-nilly say these angles are equal without justifying it. Okay? I'm going to do the same thing with angle 5 and angle 1, but I'm going to use that particular relationship. So I know angle 5 also happens to be equal to angle 1 because they are corresponding angles of parallel lines. Now, a couple of things here. The parallel lines part is crucial because as we talked about, corresponding angles are only equal if the lines are parallel. So if I simply said they're equal because they're corresponding, well, not all corresponding angles are equal. It wouldn't be enough justification. So I do need to have that part in which the lines are parallel. Now, the great thing is, I just said that angle 4 is the same as angle 1, and angle 5 is the same as angle 1. Well, by the transitive property, if angle 4 is equal to angle 1 and angle 5 is equal to angle 1, that means angle 4 and angle 5 have to also be equal. So we're going to say, by the transitive property, angle 4 will be equal to angle 5. Now the last and final thing that we need is a conclusion. Remember that conclusion is just like an aha statement, okay? I wanted to show that the alternate interior angles must be equal, specifically when a transversal intersects a pair of parallel lines. So I'm just simply going to conclude that. So the fact that I had by the transitive property is in there. I'm kind of seeing or already indicating that I see some sort of relationship. I'm just going to end things off with, therefore, the alternate interior angles of parallel lines must be equal. And that's it. So as I'm going through my proof, I'm noticing a lot of the similarities from my proofs from the previous unit, but it's just approached in a slightly different way. I still have my let statement, but my let statement's now accompanied with a diagram. I still have my math work, and I still have my conclusion, okay? So I still have those three staple parts. It's just they look slightly different. And that's it. Okay, we are going to end here today, but your job is to make sure you feel confident with the definitions. It would be a good idea to start making your own, like a study sheet or a cheat sheet with the relationships that we've talked about so far. And the things that you'll want to include is the name, the diagram, and if there's any specific math relation. So I know vertically opposite angles are equal. Supplementary angles add to 180, right? And then that way we can keep adding it as we move forward in the notes. That's it for today. Bye.